Let's try to solve the following equation. X plus the square root of x minus 2 equals 0. We now have a few different ways we can solve this. Let's try solving this in two different ways. So one thing I'd like to try is looking at it. It's kind of similar to this, which I know I can solve through factoring. And you might say, this isn't similar to this at all. This has radicals in it. This is a polynomial. Polynomials are far simpler than any equation that has a radical in it, and in a way you are absolutely right. But let's look at this. What I have is a constant, then I have an expression in the variable, and that expression squared. What I have here is a constant, and an expression with radicals involving the variable, and that expression squared. So what I could do is I could set this x and this root x. If I let this be y, then this would be y squared. I know that's very small, so what I'm going to do is I'll write it out. Y equals root x. By setting y to root x, I now have y squared plus y minus 2. I can factor this just like I could if it was an expression in x, and I get y plus 2, y minus 1, so I know y equals negative 2, or y equals 1. Given that y happens to be root x, I have root x equals minus 2, or root x equals 1. Well, I'm not going to get a negative out of my square root, so what I have is this. I can now square both sides, and I get x equals 1. Does this satisfy the original equation? Absolutely. 1 plus root 1, which is 1, minus 2 is 0. So since 1 plus 1 minus 2 is 0, this satisfies my equation. Let's try it again. Because this one is actually not too bad if I solve it a different way. One thing I can do is I can isolate the radical and solve this without using any of that, without using substitution at all. If I keep just square root of x on the left, and I move this to the right, I add 2 to both sides, and I subtract x from both sides. Now, I can square both sides, and I get x equals 4 minus, let's see, I'll have 2x and 2x, so minus 4x plus x squared. And if that's confusing, you can always write out 2 minus x times 2 minus x to get this. Okay, well now what? Well, let's move everything over to one side, and I'll even write the x squared first. So minus 4x minus x gives me minus 5x plus 4. And let's see if we can factor this. Well, looks like x minus 4, x minus 1 works. 4 times 1 gives me 4, and minus 4x minus 1x gives me minus 5x. So I get x equals 4, or x equals 1. At this point, I now go back to the original equation. And I say, okay, what happens if I plug in 4? Well, I would get 4 plus 2 minus 2 equals 0. Well, that's not true, which is something to be expected because, as we know, this method produces fake solutions at times. What about this other one? 1 plus 1 minus 2? Sure, this works just fine. So, two different methods, but the same solution both times. Both times we got a fake solution, but both times it was a different solution, but we don't really care what those fake solutions are. We're looking for the real numbered solutions to this problem. And that was all we wanted.